Hi there, Mr. Holcomb here again with another episode of The Math Behind the Modules. Okay, this is lesson 4, efficiently adding integers and other rational numbers. As I said in the prior video, an integer is a number, positive or negative. That's not a decimal or fraction. So there's a couple of examples. Other rational numbers, a rational number, the root word is ratio. So now we're dealing with values in between two whole numbers, or I can't call them whole numbers because over here they're not whole. So these are all integers. And then if I pick a value in between, now we're dealing with fractions. So that's what they mean by other rational numbers. Example 1, rule for adding integers with the same signs. Represent the sum of 3 plus 5 using arrows on the number line. So my first number is 3, and it's positive. So that tells me to start at 0 like we always do. And positive means to go to the right, and the distance is the number, which is 3. Then we're going to add 5 more, which means to the right 5 from there, and we end up at 8. How long is the arrow that represents 3? That's right here, and the length of it is 3 units. What direction does it point? Okay, right on this number line. But now we can also do a vertical number line. Think of it as the y-axis. And if we do a vertical number line, numbers increase as we go up and they decrease as we go down. So if I did the same thing on this one, I started at 0 and I went to the right 3 and then I went to the right 5 more, I'd be up here at 8. Okay, so what direction does it point? Right or up. How long is the arrow that represents 5? Well, 5, the arrow that represents 5 is this arrow here, and its length is from 3 to 8, which is 5. So the length is 5, and it points to the right. Okay, or if we did it on a vertical, pointing up. What is the sum? The sum is where we ended up, which was 8. If you were to represent the sum using an arrow, how long would the arrow be? Be 8 units long. Pointing right. So it's positive. It's 8 units long, pointing right. 7. What is the relationship between the arrow representing the number on the number line and the absolute value of the number? Okay, they're equal. So the length of the arrow is equal to the absolute value. Of that number. Do you think that adding 2 positive numbers will always give you a greater positive number? Why? Okay, the answer is yes, because 2 positive numbers, absolute values will be positive, their sum will be positive, so we're moving to the right. So I would just, we can easily say, because we are moving to the right. Both times, for both numbers. And therefore would be further right, which would be greater. I'm not going to write that all out. It's hard to write with this thick. B. Represent the sum of -3 plus -5 using arrows to represent -3 and -5 on the number line. So again, we start at 0. -3 is a distance of 3. The minus sign tells us what direction that goes, which is -3. Then we're going to go another 5 units to the left. Remember, negative means left. So now we're going to start here and go 1, 2, 3, 4, 5, and we end up at negative 8. How long is the arrow that represents negative 3? Be careful here. Distance is never negative. You take the absolute value or the length of the arrow. This arrow is still 3 units long. So how long is the arrow? 3 units. 2, what direction does it point? Left. If we were using a vertical, down. How long is the arrow that represents negative 5? Remember, distance. Direction is the sign. The distance is the number. It's the distance of 5. Direction, left. And the sum was negative 8. 6, if you were to represent the sum using an arrow, how long would that arrow be? And what direction would it point? Okay. The arrow would be 8 units long, pointing left. Do you think that adding 2 negative numbers will always give you a smaller negative number? Now this word here came into play, so I'm going to explain that up here. So if I'm at 0 here, negative 1, negative 2, negative 3, negative 4, negative 5, the further left we go, the smaller the numbers get. Negative 10 is smaller than negative 2. We aren't talking about absolute value, but we're talking about negative numbers getting smaller. Okay. Do not think that negative 1 is smaller than negative 5 because it's closer to 0. It's a shorter distance. You're not asking the distance, you're asking the smaller value of it. So the bigger the negative number, the smaller the number really is. So do you think that adding 2 negative numbers will always give you a smaller negative number? So in other words, if I added negative 2 and then subtracted another 1, negative 3 is smaller than negative 2, so the answer is yes. Because the absolute values are positive. So the sum will be a greater positive. Okay. Which is a smaller negative. Okay. The further we get from 0 on the right, the bigger the number gets, absolute value. If I'm at 10 and I go negative 10, that's getting smaller, so it's smaller negative. Bigger positive, smaller negative as the numbers get larger. What do both examples have in common? Okay. Arrow lengths equals sum of the 2 numbers. The same sign is the same as the sum of the absolute value. Okay. Same sign. So the arrow length is the sum of the 2 numbers, the same sign, is the same as the sum of the absolute values of both numbers. Okay, the arrow lengths equal the sum of the two numbers with the same sign. It's the same as the sum of the absolute values. So then we just take the sign telling us the direction. So we have this rule here. Add rational numbers with the same sign by adding absolute values and using the common sign. So decide whether the sum will be positive or negative without actually calculating the sum. A negative plus a negative will give me a negative. Positive plus a positive, right and then right, will still be to the right of 0. If I go left and then left some more, I'm to the left of 0. If I go left and left some more, I'm to the left of 0. If I go right and then right some more and then right some more, I'm still to the right of 0. Starting at 0, going left 20 and then left 15, we're going left the whole time, so the answer will be. Okay? So it said do that without finding the sum. Decide whether the sum will be positive or negative without actually calculating. So we're just talking direction. Now we're going to find the sum part. So the absolute value of 15 plus the absolute value of 7 equals 22. And then you take the sign of those and it is positive. So if I take the absolute value of negative 4 and I add the absolute value of negative 16, that's going to equal 4 plus 16, which equals 20. Then keep in mind that we had negatives here and here. So therefore my answer is going to be negative. And that's what this says back here. So go back. Add rational numbers with the same sign by adding their absolute values and using the common sign. And that's what I was showing here. I added their absolute values and shared the common sign. So if I do that again, it's going to be negative 18's absolute value plus the absolute value of negative 64, which equals the absolute value of 18 is 18. The absolute value of negative 64 is 64. So I add their absolute values. 8 plus 4 is 12, carry the 1. 6 plus that carried 1 is 7, plus 1 more is 8. And then you take the sign of the two numbers the same. And that's the sign of your sum. One more time, the absolute value of negative 205 plus the absolute value of negative 123 equals the absolute value of 205, which is 205. The absolute value of 123, which is 123. Add those and get 328, and then take the sign that they both share, and that is your answer. Okay. Example 2. Rules for adding opposite signs. Represent 5 plus negative 3 using arrows in the number order. So we start at 0, went to the right 5, then we subtracted 3, which tells us to go left 3, and we get to our location of our answer, which is 2. So my equation is 5 plus negative 3 equals 2. How long is the arrow that represents 5? That was the red one, and it is 5. What direction does it point? To the right. It'd be up if we had vertical, so I'll just say that. How long is the arrow that represents negative 3? That's my green arrow. The length is 3. What direction does it point? Left. If it were a vertical, down. Okay? Which arrow is longer? Okay, can you go back? Which arrow is longer? The 5 is longer. Okay. The arrow representing what is the sum? If you were to represent the sum using an arrow, how long would the arrow be? Okay. What was the sum, so let's go back and look. Fortunately, this is what carried over 2 pages. The sum was 2. The sum was 2. Okay, and then it says if you were to represent the sum using an arrow, how long would the arrow be and what direction would it point? So let me just rewrite this equation so I'm not going back and forth. 5 plus negative 3. So we have 5 plus negative 3 equals 2. If you were to represent the sum using an arrow, how long would the arrow be and what direction would it point? Well, if I go back and look at this, my sum arrow is 2, and it's positive, so it would point to the right. So if I were just to write an arrow for the sum, it's length 2, and it's positive, so we always start at 0, so it would be 2 to the right. Okay. 2 units long, pointing right. If it were a vertical, represent 4 plus negative 7 using arrows on the number line. Start at 0, 4. Minus 7 plus negative 7, ending up at negative 3. So 4 plus negative 7 equals negative 3. In the 2 examples above, what is the relationship between the length of the arrows representing the sum and the length of the arrow representing the 2? So now my sum, if I were to draw an arrow for it, would start at 0 and go to the left 3 units. So if you look at this, the sum arrow, the red arrow, and the positive 4 total the length of the negative direction arrow. And the direction that the sum arrow is pointing is the same as the longer. Okay. I'm trying to decide if I need to write all the length of the arrow representing the sum, this red arrow, is equal to the difference of the absolute values. So the absolute value of this is 7. The absolute value of this is 4. So if we take the absolute values and subtract them, it is 3. And then it takes the sign of the longer arrow and it points the same direction as the longer arrow. What is the relationship between the direction of the arrow representing the sum and the direction of the arrows representing the 2 add ends? Okay, add end is 4, add end negative 7, sum negative 3. The direction of the arrow representing the sum has the same direction as the arrow of the add end with the greater absolute values. Okay. Write a rule that will give the length of the direction. Okay. The length of the arrow representing sum length of the arrow representing the sum is the difference of the absolute value of the 2 items. and the direction is the same as the larger arrow, longer arrow. Okay. The direction is the same as the direction of longer arrow. Okay. So in this box we have a rule. Add rational numbers with opposite signs by subtracting the absolute values and using the sign of the integer with the greater absolute value. Okay? And we're going to do examples here on it. Okay, so let's go back one more time. Add rational numbers with opposite signs by subtracting their absolute values and then take the sign of the greater value. So it says to add absolute values. It says circle the integer with the greater absolute value. Decide whether the sum will be positive or negative without actually calculating the sum. Well, if we take the absolute value of negative 1, the absolute value is 1. If we take the absolute value of 2, the absolute value of 2 is 2. So the greater absolute value is 2. 2 is positive, so the sum will be positive. Absolute value of 5 is 5, absolute value of negative 9 is 9. 9 absolute value is greater than 5, absolute value, the sign of 9 was negative, so the answer was negative. Absolute value of 6 is 6, absolute value of 3 is 3, absolute value of 6 is greater than the absolute value of 3, and the sign was negative. 11 is greater than 1, it's negative, so that's going to be negative. Now we're going to put that into practice. Find the sum. So the rule says take the absolute value of each number and subtract them. So 10 minus 7 equals 3. The greater absolute value was 10. The sign of that was 10, so the answer is 10. Absolute value of 8, absolute value of negative 16. So I'm going to take 8 and 16. I'm going to subtract that. 16 minus 8 is 8. The bigger number was the 16. It's negative, so my answer is negative. Absolute value of negative 12 is 12. Absolute value of 65 is 65. 65 minus 12, 5 minus 2, 6 minus 1. Sign of the bigger is positive. My answer is 53. Absolute value of 105, 105. Absolute value of 126, negative 126, positive 126. Take the bigger number minus the bigger, smaller absolute value. Subtract 2 minus 0. We get 21. The larger absolute value is negative 126, so I take the sign of that. Absolute value, subtract, take the sign of the bigger. Now we're taking example 3, and we're going to find the sum of integer and irrational number. The addition of rational numbers follows the same rule as the addition of integers. Find the absolute value of the numbers. So the absolute value of 6 is 6. Absolute value of negative 2 1/4. Now this confuses some students. This is not negative 2 times a quarter. It's negative 2 and 1/4. And if I made that an improper fraction, 4 times 2 is 8, plus 1 is 9. That'd be the same as negative 9 quarters. It is a number, not a multiplication of a number in a fraction. That's a common mistake. So that equals the negative 2 1/4's absolute value is positive 2 1/4. The rule says to take 6, subtract smaller. Okay, now we have a problem here because I don't have anything over here to subtract a quarter from. So I make 6 5 borrow 4/4 from it, that's 1. 4/4 minus 1/4 is 3/4. And 5 minus 2 is 3. The larger number, absolute value, was 6. It's positive. My answer is positive 3. So we found the absolute value. We subtracted the absolute values. And the answer is the sign of the number with the greater absolute value. Okay? Solve the following problem to show you. Find the sum of negative 18 plus 7. Absolute value of negative 18 is 18. Absolute value of 7 is 7. Take 18 minus 7 and I get 9. 18 minus 7 is 11. I can't write today. 18 minus 7 is 11. The absolute value that was larger was the 18. It was a negative number, so my answer is negative 1. Okay, word problem. If the temperature outside was 73 degrees at 5 p.m., but it fell 19 degrees by 10 p.m., what is the temperature at 10 p.m.? Write an equation and solve. So it was 73 degrees, and it fell 19 degrees, and we need to find out what that would be. So we're doing it as a sum. So it's 73 degrees, and then we're going to drop 19 degrees. Down 19 is negative. So we take the absolute value of 73. We take the absolute value of negative 19. That'd be 73 19. 73 minus 19 is 54. So now my equation is 73 plus negative 19 equals 54. That's degrees function of that. Write an addition sentence and find the sum using the diagram below. So we start at 0 and we went left 10. So I would say negative 10 plus, and we went to the right, parentheses, plus 3 1/2 equals, and we ended up right here, which is negative 6 1/2. Okay? And that was the end of the lesson. Go to your problem set.